Hello everyone, welcome back to our discussion on the topic forces. Today we'll be treating equilibrium of forces. Equilibrium of forces. For a body to be in equilibrium, it must not have the tendency to rotate. That is, the total forces acting on the body must be equals to zero, or the total forces acting on the body must be zero. Now for three forces in equilibrium, we normally use Lami's theorem. Now Lami's theorem states that if three forces acting at a point are in equilibrium, then each forces is proportional to the sine of the angle between the lines of the action of the two other force. Now this is being shown dramatically on your screen. Now when we have three forces with these angles between them, Lami's theory simply states that T1 over sine omega will be equals to T2 over sine theta, which will be equals to T3 over sine gamma. Our very first question is from NECO 2003, and it states that a particle S of weight 65 kg at rest is suspended by two light strings SY and SZ, which makes angle of 45 and 75 respectively with the horizontal. Find the tension in each string correct to two decimal places. Now our very first point of action is to sketch our question, sketch our forces and the angles, and try and get the angle between each of the forces. Now when we do that, we get something as shown in the diagram. We know that our angle to the horizontal is 75 and 45, and from our knowledge of geometry, the angle below will be 90, which makes our angle between Z and W to be 165 degree, and the angle between Y and W to be 135 degree. Now for angle on a straight line, 75 plus the angle between Z and Y plus 45 will be equals to 180, which will make the angle between Z and Y to be 180 minus 120, which is equals to 60 degree. Now having simplified our angles, we can now apply Lami's theorem. But first of all, we have to convert our weight from kilogram to Newton. So and we know that W is equals to mg, which will make W to be equals to 65 times 10, which is equals to 650 Newton. Recall, using Lami's theorem, W over sine 60 will be equals to SY divided by sine 165, which will be equals to SZ divided by sine 135. Now for the first part of our question, the tension of the string SY will become SY divided by sine 165 will be equals to 650 divided by sine 160. Cross multiplying, SY will be equals to 650 sine 165 divided by sine 60, which will signify to be equals to 168.23 divided by 0.8660, which is approximately 194.26 Newton. And for the tension on string SZ, SZ divided by sine 135 will be equals to 650 divided by sine 60, and cross multiplying, SZ will be equals to 650 sine 135 divided by sine 60, which will be equals to 459.619 divided by 0.8660, which will be equals to 530.738, approximately 530.74 Newton. Our next question states that a body of mass 15 kg is suspended at a point P by two light inextensible strings SP and YP. The strings are inclined at 60 degree and 40 degree respectively to the downward vertical. Find correct to two decimal places in tensions in the strings. Take G to be equal to 10 meter per second square. Our very first point of action is to sketch our forces and look for our angle. And doing so with our knowledge of geometry and our Cartesian coordinates, we get the figure as shown on the screen. You can pause it a while so that you can follow the calculation, but it ends up with the angle between S and Y to be 100 degree, the angle between S and W to be 120 degree, and the angle between Y and W to be 140 degree. First of all, we have to convert from kilogram to Newton, where W is equals to mg to be equal to 15 times 10, which is equal to 150 Newton. Since we have gotten all our angles, we can now apply Lami's theorem. We know that from Lami's theorem, W divided by sine 100 will be equals to SP divided by sine 140, which will be equals to YP divided by sine 120. So starting for our point as is in the tension in the string sp divided by sine 140 will be equal to w divided by sine 100, and we know that w is equal to 150. Cross multiplying, sp will be equal to 150 sine 140 divided by sine 100, which should be equal to 96.418 divided by 0.9848, which should be equal to 97.91 Newton. And for the tension in the string yp divided by sine 120 will be equal to w divided by sine 100. Cross multiplying, yp will be equal to 150 sine 120 divided by sine 100, which will be equal to 129.904 divided by 0.9848, which will be equals to 131.909, approximately 131.91 Newton to 2 decimal places. We have another question from NECO 2005. It states that in the diagram above, an object of mass 10 kg hanging from a light inextensible string is pulled aside by a horizontal force S. If the string is inclined at 60 degrees to the vertical and the system is in equilibrium, calculate in Newton 1. The tension T in the string, and 2. The force S. Take G to be 10 meters per second square. Now our very first step of action is to sketch our forces and simplify our angles, and when we do that, we get that the angle between P and S to be 60 plus 90, which should be 150, which will make the angle between P and W to be 30 plus 90, which is 120. Because from our knowledge of plane geometry, the angle P will be similar with the angle PT and the vertical, which is 60 degrees. Now first we are going to be looking for W, and we know that W is equal to mg, which should be equal to 10 times 10, which is equal to 100 Newton. And from Lami's theorem, we know that T divided by sine 90 will be equals to W divided by sine 150, which should be equals to S divided by sine 120. Now for the first part of our question, the tension at T divided by sine 90 will be equals to 100 divided by sine 150, and when we cross multiply, T will be equals to 100 sine 90 divided by sine 150, which will be equals to 100 times 1 divided by 0.5, which is equals to 200 Newton. And for the second part, the force S divided by sine 120 will be equals to 100 divided by sine 50, and when we cross multiply, S will be equals to 100 sine 120 divided by 0.5, which will be equals to 86.60 divided by 0.5, which is equals to 173.2 Newton. We have another question from Y 2002. It states that in the diagram, an object of mass 3 kg hanging from a light inextensible string is pulled aside by a horizontal force R. If the string is inclined at 30 degrees to the vertical and the system is in equilibrium, calculate in Newton 1. The tension T in the string, 2. The force R. Take G to be equal to 10 meters per second. Now resketching the diagram and looking for our angle, we get the diagram as shown on the screen. Using our knowledge of plane geometry, the angle W, that is the angle between P and R, will be 120 degrees. That's 90 plus 30. Now since we've gotten all our angles, we are going to be applying Lami's theorem, recalling that W is equals to mg, which should be equals to 3 times 10, which is equals to 30 Newton. And from Lami's theorem, W divided by sine 120 will be equals to T divided by sine 90, which will be equals to R divided by sine 150. Now for the very first part, the tension in T divided by sine 90 will be equals to 30 divided by sine 120, and cross multiplying, T will be equals to 30 sine 90 divided by sine 120, which will be equals to 30 divided by 0.8660, which is equals to 34.64 Newton. And for the force R divided by sine 150 will be equals to 30 divided by sine 120, cross multiplying, R will be equals to 30 sine 150 divided by sine 120, which will be equals to 15 divided by 0.8660, which will be equals to 17.32 Newton. We have another question from WAEC 1996. It states that an object of mass 10 kg is in equilibrium when suspended by two light inextensible strings of length 4 meter and 3 meter. If the other ends of the string are fixed to 2.5 meter apart on the same horizontal level, calculate the tension in each string. And we are given a diagram of the question, a diagrammatic representation. Now, from our knowledge of Pythagoras theorem, 3, 4 and 5 is a Pythagorean triple. So therefore, the angle facing the side 5 meter will be 90 degree. So resketching that, we get the diagram as shown on the screen with our other two angles unknown being omega and gamma. So our first step is to look for omega and gamma, and we'll be doing this using Pythagoras theorem. Now we know that W will be equals to mg, which is equals to 10 times 10, which is equals to 100 Newton. Done that aside. Now in our triangle ABC, sine omega will be equals to 3 over 5, which will be equal to 0.3, and omega will be equals to arc sine 0.5, which is equals to 36.86, and also sine gamma will be equals to 4 over 5, which will be equals to 0.8, and gamma will be equals to arc sine 0.8, which should be equals to 53.13. We are applying our knowledge of SOHCAHTOA. Having gotten omega and gamma, we are going to be resketching our diagram, and doing so we get the diagram as shown on the screen. Now applying Lami's theorem, 100 divided by sine 90 will be equals to T1 divided by sine 143.13, which will be equals to T2 divided by sine 126.86. Now for the first part, T1, that is tension in one string, T1 divided by sine 143.13 will be equals to 100 divided by sine 90. So T1 will be equals to 100 sine 143.13 divided by sine 90, which will be equals to 60 Newton. And T2, the tension in the other string, T2 divided by sine 126.86 will be equals to 100 divided by sine 90. And cross multiplying, T2 will be equals to 100 sine 126.86 divided by sine 90, which will be equals to 80.01 Newton, approximately 80 Newton. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the soft copy on the website written at the bottom of the screen. Thank you.